and all that. Okay. Why I am talking about operator? Because I know from 1 or 2 months from now on, when you go to the upgrade to the next stage, your life will be completely, your Kubernetes life will be completely determined, dominated, controlled by operators. And if you are not exposed to operator at some point of time, it would be, you will have to get exposed to operator. So that's why today I talked about the operator as such, and I'm not going to talk about operator anymore throughout this delivery, because this delivery doesn't talk about any operators or anything like that. Okay.
One last question, sir. This operator,
Yes,
does it
please.
mean by the emergence of the operator, we will be working less on the Docker images because it will be handled sort of intricately by the operators itself. So you will be seeing less of the images, because when you say you want to get a Cassandra operator in place, you are actually getting the you're actually getting the manifest to drive everything. So your backend images, your the way it's being sort of stored in the repository, the way you get it from the hub. So anyway, you wouldn't do it with, so your container, everything is deployed and everything is ready made. So it makes your life much more easier, it looks like.
Yes, the operator is going to make your life much more easier, because you are not going to interact with the container or Docker image as such. But please keep it in mind, at the end of the day, it will be Docker images or container images only. Okay. And so operator is also going to use those container images, but which container image, where to find it, all those instruction sets are already intelligent. So it knows where from I'm going to get this operator, I mean Docker images, how to download them, after downloading, how, what are the services, what are the privs, and all these instruction sets. I mean, associated resources that I need to create. All these are already there in your operators. Okay. And too much of your Docker image comes in your Docker hub. Okay. Using the operator itself, you can upgrade your running application instance, which is running in a pod or something like that. So OLM, or operator lifecycle manager, is the word. An operator's life cycle, you can manage a complete applications using operator's life cycle manager. Okay. So you can upgrade a pod right from the operator itself. So this will be the greatest advantage. You can manage the application delivery. And as you become a more advanced user of Kubernetes, you can deploy a container even from source code. Okay. That is not part of this. So right from GitHub, it can pick up the complete source code, build it, develop your container, and deploy it as an application on your Kubernetes. And Kubernetes can do that, which is known as source to image building anyway. So
Uh,
so
Sir, one question here.
yes,
So, regarding this operator, so it will be getting introduced in new Kubernetes version, right? So this particular new component will be get deployed in the master nodes as we have it, and the kubectl will talk to the operators to get the pod stuff and all that. Am I right? Okay,
yes,
so
yes.
I just want to check that it's a new component that is that will be introduced in the masters servers, and all the instruction sets right now, all that kubectl is doing from the client end, going to the kube API server, and kube API server will manage all the operations related things.
Hmm.
Yeah,
Yes,
right?
that is true
Yep.
today. That is true yesterday. So
Yep.
it is all right. Okay.
And there could be many
And
operators as such as you have mentioned, because the cluster would have many applications. So not only Cassandra, but it will have some different applications. So there will be multiple operators, irrespective of our requirement, that will be going on. So it's just a new way of interaction, things, getting the things doing up and down or on the requirement of our applications.
yes, yes, that is one fundamental thing that you need to understand is traditionally Kubernetes also installed all your applications using various pods that are running inside Kubernetes. Okay. So entire Kubernetes architecture, you must have already seen this delivering it complete set of services using various pods, containers that on a Kubernetes working node, there are only two services that is running like the traditional Unix daemon service. What are those two services? kubectl and cryo or Docker. Okay, now it is Docker. Very shortly it will become. It would be later on. Very shortly it would be. So kubelet and cryo will be the only two processors running. The rest all services, APIs, scheduler, controller, manager, all these services are extended using pods. Traditionally, all these pods, when you run the command kubeadm is responsible for downloading, deploying container images, for creating all those pods. Okay. So when you do a kinit command, basically it downloads various cluster operator cluster um, pods. I mean, the pods that are responsible for running your cluster are downloaded. So various container images are downloaded by Kinit. Okay. Now, the shift that is taking place now, what will happen in coming days? Your cluster, no, uh, the pods which are responsible for running the cluster will also be using operators. So instead of downloading a cluster pod, you are going to download an operator, and that operator will be responsible installing your entire cluster. And with that, the term has now come as cluster operators. So there are two different sets of operators are now coming in the latest distribution of Kubernetes. Latest distribution of Kubernetes will be deployed using cluster operators, and upcoming Kubernetes deployments will be controlled by cluster operators. Okay. So why I have introduced because other state-of-the-art Kubernetes distributors have already switched on to this model because it is easier, advanced, more sophisticated, efficient, and future-proof. That's why Red Hat, Rancher, and others have already switched on to that. Red Hat, in a massive way, switched over to the entire
So
operator
the
architecture.
bootstrapping of
Okay.
the clusters also will be happening using like cube operators. Yeah, yeah. Okay, got it.
Yes,
Yeah.
yes,
Okay. So not
yes. That
manual way
entire
of doing it like
bootstrapping
as
that
we
will.
do it right now in the exam, but it will be using the operators related things to deploy each and every component object, you can say.
Yeah. No,
Yeah.
in the possibly in the same fashion. Possibly your KDADM will be more intelligent. KubeADM command itself is be going to do that. But right now, KubeADM pulls certain container images. It will be pulling certain cluster operators. And using those operator instructions, it will do a operator lifecycle manager. And using that, those applications, a cluster pods will be deployed. Are you getting my point?
Yep.
And that is already true. That is already true with some of the Kubernetes distribution. Whatever Kubernetes, it is IBM's cloud platform, Google's cloud platform, Azure's platform, or Amazon EKS, that is Amazon Elastic Kubernetes Service, etc. Everywhere Kubernetes is there. Okay. And the rate at which Kubernetes is expanding, and the rate which it is developing, you need to keep pace or keep abreast with the development of Kubernetes. Having said that, I don't want to confuse you anymore. Rather, I just wanted to make you aware of the developments that is taking place and the body of knowledge of Kubernetes, and what are the things that you should be already be comfortable with. And in a Kubernetes interview, if somebody asks you, what do you understand by cooperator, you should already be comfortable with operator
So
because
Kubernetes.
people who are, yes,
Sorry.
please.
So Kubernetes 1.8 version, it doesn't have operators. So is there any upgrade which will actually incorporate?
Actually, 1.18 itself, there is support for
I see.
operators.
Okay.
Okay, so if you use Kubernetes operators, okay, and because in hubs.io, you can see that already Kubernetes operator patterns, Kubernetes docs, Exchange Kubernetes operators. So already Kubernetes, this is support, current version of Kubernetes is already supporting operators. And because it supports operator, current version, that's why operator.io. If you go to operator.io, just now I went there, operator.io, here you can see each of the operators are showing you what? For example, okay, Akka cluster. If you click install, you can see that the Kubernetes command is already there. So your current version of Kubernetes already supports this. You can download it and you can run the command, and Kubernetes will use this operator to create an application in your current version of Kubernetes architecture. So it's not the idea that if you are under the impression that in the future versions of OpenShift or uh, Kubernetes, you will get to see operator. No, sir. Your current version itself supports operator, and people are doing everything using operators in Kubernetes architectures already for quite some time.
Sure, sure. Thank you. Yeah.
Okay, so
So you want to say
it is
operator hub.io is like the who manages like Kubernetes.io, we know that okay, it's a standard page.
okay.
But what about this operator hub.io? Is it like trusted source or like just wanted to,
Actually, increasingly, uh, it is CNCF, that is container, CNC is container native containers, or some organization that has come up. Majority of container related things are now being completely controlled by CNCF. 1 minute, please. Please excuse me. Hello. Which technology? Right now, I'm not in the position to talk to. Please call me later on. Okay. Okay. So, for example, Kubernetes itself, whoever is controlling and managing Kubernetes is responsible for operator.io. That means there is open container native cloud foundation, computing foundation, or something like that. So everything is now contributed to CNCF, Cloud Native Computing Foundations. Yes. So here you will find all these projects are part of CNCF. Okay. So Kubernetes, Prometheus, Containerd, Fluentd, Helm, Harbor, Jaeger, and CNI, Open Tracing, everything is part of CNCF. Okay. CRIO. So CNCF is a body which is maintained by IBM, Google, Red Hat. I mean, Google, Red Hat, they are the primary, or canonical, they are the primary sources because they are the principal promoters of open source application development. And that's why they have. Okay, so I have, I drive operator.io is also, operator hub is maintained by operator hub, uh, some by the same set of peoples. Okay, so that's why it is not owned by any particular company as such, because now developing applications or open source development model has become the in thing. Nobody wants that something should be owned by one complete company. So so this CNCF is a consortium promoted by large number of companies. So everything is owned by
Yep, got it.
CNCF.
Thanks.
Okay.
Thank you.
Okay. So having said that, so with that only, I'll be coming to today's topic, that is service. Okay. You already have seen service, isn't it? You already have some exposure with service. So I have my Kubernetes architecture installed here in this Oracle VirtualBox. I hope you all are using something like this. In your previous session, you have already deployed something like this. Okay. And usually I use Vagrant images. Okay. And because Vagrant images are efficient, and I create a master image, and thereafter if any of these images gets corrupted, I new clone, rename it, and start using it as a master or worker as situation necessitates. So in this new group, the images that are there, they are the base images. I don't touch them. Creating clones from them, I create these machines, these images, and here I these are clones of the original. So in the event something goes wrong, I just right click, delete them, and instantly come up with a new one from the original image. Okay. So that way it is very, at least it gives me lots of comfort. Okay. So usually I start using a detachable start or headless start also. You can do it. Traditional Oracle gives you the option of Oracle VirtualBox of headless start, continue running in the background. Okay. So here you can do a start from here. Now it says headless start. Okay. If you do a headless start, you won't be able to see the machine. It will be running in the background. So that way you are comfortable. And I know the IP of each of these systems. Okay. So the master has an IP address 101, worker 1 and worker 2 have an IP address of uh, 151 and 152. Okay. And I am using Ubuntu the variant of then its operating system is Mint operating system, and I am using Mint's terminal, something like this. Is my terminal visible from your
Yes, yes.
desk or desktop? Okay, if you want, then I can also increase the font size to make it even more comfortable for you. Okay, so this is it. Okay, today I'm going to talk about service. Possibly you are already aware of. On my previous delivery of Docker, I started talking about service, how Kubernetes delivers or something like that. And somebody said, "Sir, are you delivering a session on Kubernetes or Kubernetes status session has already started?" Okay. The reason I started delivering that was I talked about that is because when you learn Docker, you only want learn Docker to understand what is a container and what is a container architecture. Later on, you don't use Docker at all because once you have mastered Docker, you are more into container orchestration. And in that orchestration, or uh, container orchestration tools like Kubernetes and Mesos, they are the primary orchestrator tools. Of course, Docker itself does a container orchestration, but Kubernetes has now become the industry standard. Almost all companies have adopted them, and they are the primary method of container orchestration. So, when you deploy a container, what really happens? You deploy a container inside, for example, there will be a pod, okay? And in that pod, okay, so this is a pod, and in this is not a pod, this is a node, and this is also a node. Here, inside a node, you are going to deploy what? you are going to deploy a pod. Okay. So your application pods will be something like this. This is an application pod, and these applications is running an application named app1. Okay. So this is an application pod. Okay. Now these application pod can have multiple replicas. That means the same pod could be running here too, and it could also be having one more copy here too. Okay. So it has three replicas. Application that is running in three replicas. Now, the problem is, how do I access these applications? Isn't it? Each of these applications are having, these pods are having their own IP address. That IP address has already been allocated from the pool of IP address that you have specified at the time of installing Kubernetes, isn't it? So you need to find out a method of putting all these applications in such a fashion so that anybody can approach these applications from outside world. Okay. Now, Kubernetes does everything, uses a resource type. I said does everything using resource type. That brings us to the concept of what is a Kubernetes resource type. In Kubernetes, everything that or anything that you create using Kubernetes resource type. For example, a pod is a Kubernetes resource type. Okay. A network is a Kubernetes resource type. A node is a Kubernetes resource type. Anything to everything is a Kubernetes resource type. You are already exposed to Kubernetes resource type lot of time. You are already dealing with deployments. A deployment is also a Kubernetes resource type. Okay. So here you are running as pod. You have to find out a method of connecting to the applications that are running. Let's assume on all these three pods, a web server is running. How do I connect to this web server? Okay. To do that, we create a Kubernetes resource. Name of that resource is service. Okay. This particular service resource is basically, it defines a set of applications. Okay. That means usually a service is associated with a set of application pods. Okay. So when somebody approaches this service, this service will automatically take you to one of the associated pods. For example, it would be connected to this one. Similarly, it would be connected to this one. Okay. And similarly, the same service will be connected to this one. Okay. So what is happening? When you connect to this service, this service represents all these three pods. Okay. So by default, a service is expected to be load balanced. Load balanced means, let's assume there are three web servers running in these three pods and a service is attached to these pods. First time a service is attached to these pods. When the service is attached to these pods, the define service network at the time of installation itself. Okay, let's define, you have already defined the service network, and from that service network an IP has been allocated like this. Every service is associated with an IP. Okay, this IP is network. Okay, so OpenShift basically builds with by default three different kind of network. Okay, so let's get into. I have already created a presentation possibly, and there, yes, here it is. So what is a service? An abstract way to expose an application running on a set of pods. Okay. Okay. So this is what a service is all about. It is an abstract way of defining an application running on a set of pods. Okay. And they are typically assigned with. Now how OpenShift service will get connected with each of these, because in your cluster, what really is true, there will be hundreds of application pods running, isn't it? Now, how this service will come to know to which particular application pod I should be associated with? There are three pods that are associated with this service. But how this service will come to know that? Because tomorrow, if this application pod gets deleted, okay, because number of replicas in OpenShift can be dynamically increased or decreased. Okay, we are already aware of that. We can create number of replicas and we can increase the number of replicas. We can decrease the number of replicas. So number of instances could dynamically change. So how your OpenShift service will come to know that I should be attaching to this? Okay, so that's the problem. So here, service always is aware to which particular application pod it should be connecting to, because each application pod has a label. Okay, there's a label, and that label is unique in a particular namespace. Okay, so you create a Kubernetes application in a namespace. Okay, and in that namespace, you create a deployment. That deployment itself deploys multiple replications of the same application pod. And in that namespace, you create a service. And that service automatically gets attached to this. This is the logical flow that happens in Kubernetes. Now, there are three different sets of IP addresses you can see here. One is node IP. Each of these nodes, these are nodes. This is a node, this is a node, and this is a node. Each of those nodes will have an IP address. That is primarily, it's a IP address provided by your physical or cloud infrastructure deployment, or it could be in VMware infrastructure or in your local traditional good old physical machines or virtual machines, wherever it is. But this IP is your part of your traditional physical IP network. Okay. So from that only your network administrator has provided or set the IP address of these nodes. Okay. So this is one set of IP. Now, again, your nodes could be distributed in multiple geolocations, isn't it? Your one Kubernetes node could be here. Another Kubernetes node could be in Hyderabad. One is Bangalore, one in Hyderabad, one could be nodes or IP address. In that case will represent your net IP. Okay, so this is one network, that is the network of the node. Okay, now Kubernetes also creates a cluster network. Okay, This cluster network, what does it represent? Okay, this cluster network represents whenever you create a pod, an IP address is instantly allocated to the pod from the cluster network. Okay, so what would be the cluster network that you define? Pod, an IP address is assigned to it. Okay. Second, you create a service, and then this service is also allocated or associated with a particular IP. This IP traditionally is known in a Kubernetes interview. Typically, people ask to confuse you. What do you understand by what is the difference between cluster network and service network? Okay, pod infrastructure. Each and every pod, when deployed, gets an IP address. Okay, that is delivered from this pool of IP address. Of course, there are certain infrastructure pods which don't get allocated these IP address. Rather, those pod IP address could be inheriting the node IP address. Okay. Anyway, so and there is another service network. This service network, whenever you create a new service, an IP is allocated from this service network. Okay. Okay. So is there any question?
Who will create this service network, or it is by default?
Okay. Okay. Who is going to create this service network? Okay. Why this done? Okay. Not share. I should be doing a present. Yes, I was showing you a small. Actually, at the time of installation itself, you can define this. QVDM init, if you go through the parameters of QVDM init, okay, you will find out it takes lots of tons of parameters, okay, to custom design. If you do a QVDM init, okay, that will take you to the QVDM init, okay, and that will take you to the documentation page of Kubernetes, okay, and here it will show you what are the parameters that you can pass on, okay, and this will tell you what all it does, and it is very informative. The instructor is not going to talk about each aspect of this, but you can enlighten yourself by going through this kubedm init page. Okay, that will answer many of your queries you have in mind and you are not asking because others are not asking. Okay, so please go through this. That will clear many of the doubts. Second, here comes the options. In these options, you can define whatever parameters that you want to. So this cluster network, that is this pod network address as well as the cluster network address, all things could be customized from your qadm init command itself. Okay, you can create a custom YAML file at the time of init itself. You can pass on that file itself as a config YAML parameter. QADM will read this config YAML parameter file itself, and from that itself, many of the parameters could be passed on. Okay, and please go through this document and you'll find how to pass on various parameter phase join upgrade parameters that are possible to pass on to cube init itself. Okay, so I'll request you to do that.
No, no, I did ask because the first class for the installation of the Kubernetes cluster like these particular parameters was
complaint for port. So you just put this port as port equals to, okay, 8080. Okay. Or you can say port 80. Okay. Control L. Now, what else has been created? kubectl, kubectl get svc. Okay, you don't have to type service. So this svc or service was already running. We have created a new svc. Okay, so all the resources that are getting created from Nginx also inheriting the name Nginx. Okay, the deployment was named Nginx. So therefore the service that you created, that has also has the name Nginx, and this has an IP, cluster IP. This cluster IP is basically what I'm trying to impress in your mind. It is the service IP. Okay, then whenever you create a IP service, it gets an IP, and that IP is known as cluster IP. Now if you compare this with this, okay, this cluster IP is different from the pod IP address. So each of these pods, okay, now service, okay, if somebody comes to approaches this, it will lead to this. Okay, how do I know that? Okay, OC, sorry, actually we are working both in Kubernetes as well as OpenShift as well as the Rancher. So what happens, those commands gets confused. Okay, sometimes I'll be started typing OC, please bear with me. So what I can do, I can do one thing. Okay, control K. So even if I type something wrongly OC, I can do an alias. Okay, OC equals to kubectl. Okay, so even if I wrongly type OC sometimes, there'll be absolutely no issues. Okay, because OpenShift client command is OC. Okay, OpenShift is another distribution of Kubernetes, just like Rancher. Okay, anyway, so kubectl, please you don't do this alias OC equal kubectl. This is only just to sort out the problem of my life because I am often type I often type OC even when in Kubernetes because I am not I just forget in which platform I am working. Okay, so if you describe SVC, okay, and if you press tab twice, it will prompt. There are two services possible. So it will describe that cluster IP is this, but when you approach this, it will always take me to this IP address. Okay, so if I approach this IP, is it going to take me to this approach IP? I'm not really too sure. Let me try it. I am approaching the cluster IP. Okay, yes, I am getting a welcome to Nginx. So I am getting time. I am doing a call to the cluster IP. Okay, up to this, everybody, it is clear to everybody.
Can you also say curl to the endpoint
Yes,
IP?
yes, I can
Yeah.
also do the curl to the endpoint IP. Okay, we are getting the same thing. Okay,
And one question is the pool of IPs which you are allocating to the SVC.
yes.
At some point of time, does it exhaust in a big environment?
Okay, in a big environment. Okay, so in a big environment, it is usually from a cider pool. Okay, that cider pool at class 2. So your OpenShift infrastructure is not likely to be that large. Even if that happens, you can create multiple cider pools, and in fact, in one OpenShift, you can have OpenShift cluster itself, you are not going to accommodate that many type of applications. You can very well imagine in a class B kind of IP is possible. There are network guys sitting here who can give me a much more precise figure.
Class B.
172
Okay.
something like that, a CIDR pool 172.20.0.0/16. So that would be a huge number of IP addresses in one OpenShift cluster itself. That would be more than enough. In fact, you are not going to consume even 1/10 of that. Okay.
Okay.
So, and yes, even if it is larger than that, there are various SDN plugins that you are going to use with your Kubernetes, that is Calico, etc. And more importantly, that is Big Switch. What is that? Arista's new infrastructure SDN tool for pod network, which is becoming the most popular and in thing, that is Big Switch. So they are all capable of doing that. Okay, but I am not going to talk about that because that will confuse you as well as me also. I am not also too much expert or much of an expert on those. So anyway, so we have seen that this is the service that has been created. Okay. Now let's assume we are going to increase the number of pods. You can also use this command kubectl get EP. EP stands for endpoint. So right now it tells you endpoint represents what? Each time you create a service, it defines an endpoint because to which endpoint it will lead to. Now let's increase, okay, kubectl scale, okay, deployment replica equals to 3. Okay. So now we have scaled it, isn't it? So if we do a kubectl get PO, we have 3 Nginx pods now running. Okay, now if you take a look at the kubectl describe service Nginx, you can see the number of okay. Now how this particular service is aware that it should get attached to this pod and running, isn't it? Okay. So if I try to assert an OC get PO, these are running in the current project itself. In the entire infrastructure, there are a lot many other pods running. Okay. So minus all namespaces that will tell me there are a large number of pods running. Okay. So how your SVC is aware that I should only get attached to this one? Okay. How should I get attached to these pods only? So what is really determining that? You can see app equals to labels, app equals to Nginx. That is, whenever you create a service that has some special features, app equals to Nginx is you always attach to an application that has a label Nginx. So let's find out where this Nginx app is attached in the pod itself. Now, if you try to run the application label kubectl, okay, and kubectl get, okay, PO minus O YAML. Okay. And I do not know the pod itself. Okay. So get pod. Let us take any one of the pods. Okay. Minus O YAML. So here you see each of these pods will have a label. Okay. And that label itself says that, and it has a label named Nginx. Okay. How this containers image policy always name Nginx, and it also has a label Nginx. Everything it has you are creating a pod, and this pod is also with it associated with the app :nginx labels. Can you see that? So every pod that is created, so the service itself tries to find out all pods that has this level, and it automatically gets attached to that pod. Am I clear? If not, please ask me to repeat it. I'm going to repeat it.
Yes, yes.
Should I repeat
So
it?
all the endpoints here are managed through the labels, and the service will use the labels to get the same,
Identify. Yes.
identify all of these things.
Services, yes. Service will always identify as to which pod I should get attached to. And usually that is identified by using a pod application label. Now, how this application pod is labeled? The moment you create a new deployment, okay, when I have created a new deployment, and the command that I used, okay, is this. Just in front of deployment, I have typed Nginx. What will happen? This deployment, whenever it creates the new pod, it will create this application app level. Basically, it creates a new application pod, and every resource associated with that pod will inherit the name Nginx. That's why whenever you create a deployment type resource, it will not proceed further unless you type the name of this. So it is creating a resource deployment, and each resource should be uniquely named in a project. It can be, it may not be unique in a different project. Okay. So there could be another Nginx thing in another project, but in the same project, you cannot have.
So the project means the namespace here, right?
Two
Okay.
deployment.
Okay. And if we have a
Yes,
custom
yes,
YAML
yes.
file, like not from the Nginx, but in that YAML file, we should make sure that the label is there for that app.
Yes, a deployment type is any YAML type that we are going to use custom YAML anyway. In fact, in my next exercise itself, I am going to use a custom YAML where I'll force you to type a lot. Please bear with me because that is part of my job, where we are going to do a lot of time and to customize many of the things. Okay. And in fact, I'll show you how to dynamically edit this any aspect of your deployment, etc. Okay. So having said that, should I take a break for 15 minutes? Is it all right?
Yes, okay.
Sir, one
Sure.
question here.
Yes.
Sir, just one thing. Sir, when we deployed this cluster setup, what we have in this thing, so it didn't have that service network. So if we don't have that service network and still execute this command, it will work, or it will cause an error, or we need to do some reconfiguration.
No, actually, it will not do a error as such because by default, a service network is already defined. Okay. So whenever you do a QADM in it, okay, that itself will define a service network. Usually, it is defined from uh, defined from usually from your parameters. You can custom control it, or it will define its own
Okay, so
parameters.
no need to do anything now. It will work.
Yes,
Yeah. Okay, sure.
yes, it will work
Thanks. Yeah.
because without a cluster network, that is service network, it will not work. OpenShift knows that. Kubernetes knows that. So that was by default, it will create a one.
Yep. So, and all
Okay.
the deployments which you're doing it on a master node, we have not seen it on the another worker node, right? Because we have not seen much of the commands that we executed on the worker node.
Okay. Now, in fact, on worker node, you don't do anything. Okay. For example, you always, whenever your company does a pre-sales or something like that, he primarily talks to the sales manager or something like that, and he will do everything, every entire communication. He will pass on the orders to others. In fact, your manager is master node is the manager. In real world scenario, manager will not do anything. That means not a single pod will be created in the manager. In the manager node is made unschedulable. That means you cannot schedule a pod on the manager. Whatever instruction sets that you do give, by default manager will ask the worker, you get this job done. Okay, so all the pods are scheduled on the worker pod. Is it clear?
Oh
Because
yes.
because we
No,
have a
but why I'm asking because when we add that worker node, so I've not seen any much commands that executed on the worker node. So I thought like, yeah.
you are not going to execute any command on worker node. In fact, we are not supposed to execute any command on the master also. Are you getting my point?
No,
This
but
is
my thing is like troubleshooting node related, worker related, if any issues with communication or any errors. So how we will go on a worker node and see what things are there? Because when I executed a
okay.
kubectl command, it said that connection refused, and yeah, obviously it is talking to kube API. But what's the point of
Yes.
installing all the packages like kubeadm and kubectl, the packages installed on the client side, right?
Okay. So
So it was just a doubt query.
yeah, no, no, it's all right.
Like,
Whenever you have a doubt, you should always raise and don't feel defensive because that's why you have come here, isn't it? In fact, Kubernetes architecture is something like this. You always connect and go to the master and talk to the API server. Okay, API server then gets the job done on the worker nodes, and these worker nodes is running a particular daemon service known as kubelet. Okay, kubelet connects to the API server, or API server connects to the kubelet and gets the job scheduled on your worker node. Okay, so you never connect directly to the worker, rather always connect to the master's API server. And API server is the place which connects all everything to this. There is one more diagram I have created. This one, yes. Something like this. Something like this. API server communicates to the control manager, scheduler, queue proxy, kubelet, everything. Every communication is communicated by API server. Stores each desired state configuration, etc., in its CD. None of these tools can directly communicate to its CD. Kubelet, etc., they communicate to its CD using the API server itself. For example, what is the desired state, what is the current state? So API server, everything is done on the master node. So basically, the kubectl command itself always communicates to the master node. Okay, and the master itself gets the job done on others. At any point of time, if something goes wrong, okay, uh, on the worker node, for example, if the kubelet service is not running, then you need to physically do an SSH onto that master node, onto that worker node, and investigating what has gone wrong. Now, this has also now is coming up with a fresh problem. Fresh problem is now the master nodes or even worker nodes are getting configured using core OS, and core OS is something immutable. Immutable means unchangeable. Anyway, we'll talk about that later on after the break.
sure.
I
Yeah,
hope
yeah.
I have answered.
Yeah, sure. I got your point.
Okay.
Thank you.